Hey everyone, we're gonna start this video by picking up on the bottom of page 29. In class, you should have gone over the normal distribution. You should have gone over using the table. This table here is provided in your course packet. Looks a little different, but it covers the same numbers. And you should have gone over using the calculator to do normal distribution. So whichever method you prefer, we're going to continue on and use that method. And I'm going to show you how to use some applications of the normal distribution. And so what we're going to do today is we're going to calculate z-scores, and we're going to find the area under the curve. We're going to assume that the variable we're interested in follows the normal distribution. So you can either use the table or you can use the calculator to figure out the area under the curve of a normal distribution. Okay, so let's go ahead and fill in the blank part here. So the procedure for finding the area under the curve, it's different depending on whether you're using a calculator or the normal table. But the first thing you want to do is sketch the normal curve and label the mean. You can also label the standard deviations. I usually don't do that. And then you want to shade the area you are interested in. All right, and then the second thing you're going to want to do is calculate a z-score. Now, if you use the calculator functions, you can skip this step because the calculator will do that for you. However, you should still know how to calculate a z-score. And then the last thing is you use your calculator or table to look up the area under the curve. So the area under the curve corresponds to the probability or a percentage. The area under the curve is always between 0 and 1. And so we'll go ahead and just get started with a problem here. And so the problem deals with IQ scores. We're going to assume that they follow a normal distribution. And we're given the fact that the mean is 100 and the standard deviation is 15. And so we want to know the probability of an IQ score being greater than 130. So the first thing we want to do is draw a picture. That's already done. This is the normal curve. It's a density curve that's symmetric. And we know that the mean is 100. So I can go ahead and put 100 in here. And then we want to shade the area to the right of 130. So I'm just going to estimate where 130 is. I'm going to say it's all the way over here. And what we want to do is find this area right here. We want to know the probability of an IQ being greater than 130. So that's going to be to the right of 130. And so I'm going to show you how to do this on using the formula and the table, and then I'm going to show you how to do it using your calculator functions. So if you're using the table, if you don't have a calculator or you prefer not to use it, what we're going to do first is calculate a z-score. So we take the value that we're interested in, which is 130, and then we subtract mu, which is the mean. We're given that as 100. And then we divide by the standard deviation, which is, in this case, 15. And so this is equal to 2.00. Alrighty, so once I calculate a z-score, I'm going to use the normal distribution table to look up the area. The normal table, we have to remember, gives us the area to the left. So the z-score is represented by the first column and then also this top row. So the columns go out to 1 decimal, and then we go to the particular column for the second decimal. So the first column goes to 1 decimal, so we want to look up 2.0. So that's going to be down here. So we have 2.0 here, and it's 2.00, so I just go right here. So the area to the left, because the table gives you the area to the left, is going to be 0.9772. So I'm going to go back to my notes, and I'm going to write in the area to the left here. So 0.9772. However, that's the area to the left. That's this area right here. We want this area to the right. So we know the area under the curve is 1, so I can use that information to get the area to the right. And so what I would do is just take 1 minus 0.9772, and that's equal to 0.0228. And that's my final answer. Okay, so things to point out would be that if you want the area to the right and you're using the table, you need to subtract from 1. All right, for the calculator, folks, what we need to do is go to the function normal CDF. And so I can go to where it says stat. And then, oh, I'm sorry, I don't go to stat. What I do is I go to second, and then this VARS. And that didn't work. Let's just clear that. So I go to second, VARS, and then the normal CDF is that second function right there. So I click normal CDF. And then what I want to do, I want to give it a lower bound and an upper bound. Because I'm looking for the area to the right, my lower bound is 130. And then when we want the area to the right, for my upper bound, I just put in a very large number. So I'll enter maybe a couple nines, maybe 6 nines, comma. So I have lower bound, comma, upper bound, comma, and then I want the mean, and then the standard deviation. So I click 100, and then 15 for the standard deviation. Okay, so lower bound, upper bound, mean, standard deviation, and then I just hit enter. And it gives me the same answer, 0.0228. The answers might be off a little bit when you use your calculator, and that's fine. In this case, it gave me the same answer. Alrighty, so let's go ahead and move on to a different problem. We're still dealing with IQ scores. We want to know the probability that an IQ score is between 85 and 130. So I can do that either on my calculator or using the table. And again, I want to draw my picture. I have 100 in the middle. 85 is going to be over here. And 130, we've already colored that in about right here. What I'm doing is I'm looking for this area in between. Hopefully you can draw that a little neater than I did. So if you're using the table and the formulas, if you don't have a calculator, what you need to do is calculate 2 z-scores. We can find the area to the left of 85 and the area to the left, the area to the left of 130. And so I calculate 2 z-scores, find the area to the left of 85, area to the left of 130, and then subtract the 2. And if I'm using the calculator, I can use the same the same functions, normal CDF. We'll get to that in a second. So my 2 z-scores then would be, the first one would be 85 minus 100 divided by 15, and that's equal to negative 1.00. And then I already calculated the one for 130. We got 2.00 for that one. And then I need to look up the area to the left of negative 1.00. So I go to my normal distribution table. And here's negative 1.0. I go out to just the first column because it's negative 1.00. And the area to the left is 0.1587. So I'm going to go back to my notes and record that. So 0.1587. And then we already got the area to the left of 130. That was 0.9772. We did that for the first problem. So now that I have the two areas, the area in between is just the difference. I'm chopping off that area to the left. So I'm chopping off the area to the left of 85 from the area to the left of 130. And that leaves me with the area in between. So what I'm going to do is take 0.9772 minus 0.1587. And so when I do that, I get for my final answer 0.8185. 0.8185. Okay, so let's go and do this on the calculator. What we want to do is go back to the normal CDF. And again, we want to enter our lower bound and our upper bound. And our lower bound here is going to be 85. Our upper bound is going to be 130. Our mean is 100. And our standard deviation is 15. Lower bound, upper bound, mean, standard deviation. Then I hit enter and I get 0.8186 for my final answer. Okay, and so before we move on to the next video, you covered some of this in your class the other day, but we want to do the reverse. So we also want to find a value for x given a z-score. So these hints, finding values for known areas, will help you to distinguish the two types of problems. So the first thing is not to confuse z-scores and areas. A z-score represents the number of standard deviations above or below the mean a value is. And the area represents a probability, and that's when you use the table or your calculator. Make sure you choose the correct side of the graph. So look for keywords such as greater than or more than, less than. We did an example where we found something that was greater than a number. We could certainly do less than as well. A z-score can be negative or positive. If the value is below the mean, it's negative. If it's above the mean, it's positive. And then areas or probabilities are always between 0 and 1. All right, so if we want to do the reverse of this, we want to find the values for a given area. We still want to start out the same way. We want to sketch a normal distribution and shade in the given probability. And the next thing we would want to do would be to look up a z-score for the given area. So number 2 here, let's see, is look up a z-score. Now, if you're using your calculator, then you can actually skip to step 3. Use either your calculator or the formula to solve for x. Okay, so we'll pick up where we left off in the next video.